For the UI application deployment, we have created the Docker image and we pushed the image to the Docker Hub. So this is the image which we pushed into the Docker Hub. From this, we have directly deployed the application into the OCP environment. For this, we have created the two configuration files. One is the Docker file to generate the Angular build. Another one is the Nginx configuration.
With these changes, we have deployed the UI application into the OCP, and this is the image stream, which actually referring the image from the Docker Hub. For the API application deployment, we directly used the OC new app command to deploy the application.
This is all about the first task. Within 2 hours of time, we have completed this deployment. Moving to the task 2. As part of the task 2, we have completed these 3 items. We have configured the HPA for both the applications. And we have deployed the MySQL with multiple pods and with persistent storage with help of stateful set and headless service. And also we have added the health check. Here I am showing the HPA which we configured for both the API and UI application. And I will open the one of the HPA YAML file. Here we have mentioned the min and max replicas. Also we have configured the scale up and scale down policies. Next, I will show you the MySQL deployment with multiple pods. So this is using the headless service so that the API can able to reach the database directly by skipping the load balancer. And it is using the persistent storage so that even if you are restarting the database on API, the data won't get deleted. As part of the task 3, we have completed these items. First one is we have configured the TLS route for both the applications with the auto redirect. And we have moved all the environment related configurations to the config map and the secrets to the secrets config. And we added the network policies and we have modified the course policy for the API and we have removed the access control header from the Angular application. I'll show you one by one. These are the TLS routes for both the applications. This insecure traffic redirect will ensure that if the user enters the HTTP URL, it will automatically return the 302 response and it will automatically redirect the user to the secured HTTPS URL. Here I'm highlighting the 302 response from the server when I'm entering the non-secured URL. This is the config map we created for the API application, and we have moved all the environment related variables like a database connection string and a database name to the config map resource. And we have moved all the secrets like database passwords and JWT secret to the secrets config. The next one is we have updated the course policy in API application. We have updated the proper domain name. Actually, this can be configurable. We can move this configuration to the config map. The next one is we have configured the network policies for the database with ingress rules. So with this, we are restricting the connection to the database outside of the current namespace. The last one is we have removed the access control header from the Angular application for the security purpose. One thing I forgot to tell, the whatever secrets we have configured here is base64 encoding. So it is actually not doing any encryption. But the action solution here is we have to use proper vaults like HashiCorp or sealed secrets.
Before moving to the next task, I will quickly show you the application demo.
This is the application URL for the UI. So I'm entering my username and password. Click login button. So the application is successfully getting logged in. And, I'm able to see my dashboard and my transactions here. From the Angular application, the API calls are happening to the backend API. So here, this is the backend API URL. As part of the task 4, we have built out this dashboard application, which will show the live metrics of all the pods which are hosted in current OCP environment.
Basically, for monitoring solution, there are multiple industry standard solutions are available in the market, like Prometheus or Grafana. We tried to install different monitoring stacks, but we faced the challenges like resource constraint or permission related issues. So due to time constraint, I quickly built a simple monitoring tool with the help of GenAI.
So here the first graph shows the memory utilization of the pods. So assume that if you want to specifically see the metrics for the database, then you can select that alone. I'm just unselecting other two pods. So currently it shows only the metrics for the database pod. The second graph here is the CPU utilization of all the pods. Similar to this other graph, you can able to filter the pods here. The bottom one is a grid view of all the pods here. So it's not doing any aggregation. The other two graphs are doing the aggregation for all the pods and showing the graphs here. But the bottom one is not aggregated, so it shows the individual pod level metrics and the creation time and the container name, everything. This contains all the basic grid features like filtering, sorting, all the things it is having here. Here also you can zoom the timeline. I'll show you that. So I'm just selecting particular time frame, and if you want to zoom it, then you can zoom it, and also you can reset it. Time shows here in UTC. So for demo purpose, I just kept UTC only, but we can able to change it based on the local time zone. So currently it is showing only for a single namespace. So if you want to change it for multi namespace level, then we can able to do the modifications. And also we have built one small settings page. So in this we can able to configure the base API URL and the namespace and the token value we can configure, and the polling interval seconds. So this polling interval seconds will be deciding how frequent this application can go and fetch the metrics information from the OCP cluster. And then last one is threshold limit to show the alerts, but currently I just kept it only for the CPU level. So here the meaning here is if the CPU limit exceeds the 80%, then it will show the alert. I will perform small load testing and show how this works. So I will run the load testing. For that I just hit a single URL with 10 users in parallel, and the duration for the load testing for 10 minutes, and I will do the ramp up setup also here. Okay, I'll hit the run button. The load test is running now. So now you can see that there is a spike in the CPU utilization for the API pod. CPU utilization is increased more than 20%. Vertical scale will be automatically getting adjusted based on the data points. In the bottom grid, it shows the alert for this particular pod. So currently I have configured as 20% as a threshold limit, so that now the pod utilization level is increased more than 20%, so that it is highlighting now. Okay, now I'll stop the load testing. So now there is no load in the server, so that the CPU percentage got reduced less than 10%, and the alert also got removed from this grid.
I'll quickly show you the demo on HPA autoscaling. Actually, this was the ask from one of the core hackathon judge. So this is my HPA configuration. So here I have configured a minimum 1 replica and a maximum 3 replicas. And these are my autoscaling rules. So currently there is one pod is running. Now I am running the load testing. After the CPU limit reached more than 50%, the number of pods are getting increased by the HPA. Now I'm stopping the load testing. Now the number of pods are getting automatically reduced.